This video is about describing, exploring, and comparing data. In particular, we want to be able to answer three questions. Is the data value significantly high or significantly low? If we have two sets of data, do they tend to be similar, or does one tend to have higher values than the other? And finally, do we have outliers? First, let's look at some graphs. If we have data, a list of numbers, we can put them on a number line and construct a dot plot. For example, 0.5 is this dot. We have the number 1 4 times, so we have 4 dots at the number 1. Our largest number is 19, so we have 1 dot at 19. A histogram counts the number of dots in each class or bin. For example, between 34 and 36.99, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 dots. So we have a bar of height 13. A box plot shows the quartiles, the regions that contain 1/4 of the data. The first whisker between the minimum and Q1, the first quartile, contains 1/4 of the dots. This box between Q1 and the median also contains 1/4 of the dots. The second box between the median and the third quartile, Q3, also contains 1/4 of the dots. And the final whisker between Q3 and the maximum contains the remaining 1/4 of the dots. The interquartile range, the IQR, is the length of the boxes. It can be calculated by subtracting Q3 minus Q1. For this data, that would be 36 minus 23. So the IQR equals 13. Our first question was about significantly high values and significantly low values. We're going to use something called a z-score to answer that question. The formula for a z-score is our data x minus the mean x bar divided by the standard deviation. Or for our population, the mean is called mu and the standard deviation is called sigma. If z is less than or equal to 2.0, then we have a significantly low value. If z is greater than or equal to 2.0, then we have a significantly high value. If z is between -2 and +2, then we just have an ordinary z value which is not significant. If you want a refresher on less than or equal to, or you're not familiar with -2 is less than z is less than 2, you can go to Canvas, the home page, and click on Resources. Example 2 from section 3-3 of the book is about blood platelet count. If the count is too high, you might have too many blood clots. If the count is too low, you might bleed too easily. Significantly high values are at least 2 standard deviations above the mean, or z is greater than or equal to 2.0. Significantly low values are at least 2 standard deviations below the mean, or z is less than or equal to 2.0. I've indicated the significantly high values and significantly low values in red. In the example from the book, x bar is 239.4, the standard deviation s is 64.2, and we had a data value of 75. Using the formula from the previous slide, we can calculate that z is -2.56, which is less than -2, so this is a significantly low value. The next question was about comparing two sets of data. Do the two sets of data tend to be similar, or does one tend to have higher values than the other? If we have two sets of normally distributed data, or bell-shaped sets of data, then we can use the mean, here in green, and the standard deviation. The mean minus the standard deviation, and the mean plus the standard deviation. Mean minus the standard deviation, I use a red marker, and mean plus the standard deviation, I used a red marker. To compute these markers, I went to Graph menu in StatCrunch, dot plot. I checked the mean marker. I went to the custom button and created mean parenthesis x parenthesis minus std parenthesis x parenthesis, and checked it, made it color red. And then I created mean open parenthesis x close parenthesis plus std open parenthesis x close parenthesis, checked that, made the color red, and clicked compute. We can see here that the typical interval between the mean minus a standard deviation and the mean plus a standard deviation for men overlaps with the typical interval for women. So we're going to say that the hip girth for men and the hip girth for women tend to be similar. If these intervals did not overlap, we would say that the hip girth for men and the hip girth for women tended to be different. If either data set were skewed or had outliers, then instead of using the mean and standard deviation, we would use box plots. If the boxes in the box plots don't overlap, then we're going to say that one set of data tends to have larger values than the other. In this case, for breakfast cereals, adult cereals tend to have more potassium than children's cereals. On the other hand, adult cereals tend to have similar amounts of calories as children's cereals. The box plot for children's cereals looks strange because the box has been smushed into a single line. That's because Q1 and the median and Q3 all have the same value. For this particular example, we would also say that the adult cereals have a much larger spread than the children's cereals. Our final question was about outliers. Earlier in this class, we just looked for points that were far away from the other points. Now we can use a modified box plot calculated by StatCrunch to decide whether a data point is an outlier. StatCrunch will use a dot to show the outliers. These are the formulas StatCrunch uses, but we don't need to memorize those. Instead, we'll just use StatCrunch to create the modified box plots. For the potassium in breakfast cereals, we can see that children's cereals did not have any outliers, while the adult cereals had 2 outliers. If we hover the cursor over these 2 dots in StatCrunch, StatCrunch will give us the value of the potassium. To create this box plot in StatCrunch, go to the Graph menu, select Box Plot. Under Other Options, check Use Fences to identify outliers, and check Draw Boxes Horizontally, and then Compute. And that concludes this video.